2 weeks. So for
this call is now being recorded.
The last for 2 weeks macam happy hour lah. So this is we start learning how do we present the document, how do we perform the ranking lah. Okay, so this is week 3. I will start the assessment next week. So the quiz will start next week lah. Okay. I will post this week, but the due date will be next week. So all of you, you need to make sure that you will take that quiz lah. Okay, let me share my screen first. Boleh nampak?
Boleh, sir. Boleh, sir.
Okay. So siapa lagi yang belum scan di attendance? Nanti kita go around when we almost finish lah. Okay. So for this week we will start the actual lesson for information retrieval. So we will look into the modeling. This is called classic model, in which these are a few models that were introduced earlier. Of course, there are variant of model yang sudah advanced, tapi this is the basic foundation of how do we present document, how do we define the structure of the document to be presented to the system, and then how do we compute the ranking lah. When I said ranking, it refers to the degree of relevancy to the query. Okay. So for this lecture, we will look into the introduction to information retrieval model. We look into the basic concept. How do we present the document to the system? How does the system interpret the document as it is? And then be able to compute the ranking of the document with respect to the query. So the query referring to the keyword that we type lah. Okay. So there are a few models, the Boolean model, term weighting, and then they introduce the vector model based on the term weighting. And last one is we look into the formula that we use in order to represent the document, and also how do we compute the ranking lah. Okay, so we will look into that for today. You can stop me anytime if you have any question or if you do not understand. And because I think this is the most important part, due to the fact that all the things that you study later on will be based on this, will be based on the classic model. Okay. So when we talk about modeling, we are talking about the processes involved that we use in order to get the document. We look into the content of the document, and then we design a data structure that can be used in order to represent the document. And then when we have the representation of the document, then we can perform the ranking based on the query lah. So we will also look at the ranking function, in which we assign some kind of scoring to document with regard to a given query. So we can compare which document is more relevant with respect to the query by using this ranking function. Okay, so there are two main tasks that we have to look into today. The first one is how do we represent the document and the query in terms of numbers, okay, in terms of data structure. Okay? And then after we formulate the framework for representing document and query, then we look into a formula or a ranking function that allows quantifying the similarities among the document and query. So we will look into how do we actually perform the ranking function for this document and also for the query. Okay. So for the IR system that we look into, we will adopt the index term. Index term referring to keyword or term that we can use in order to describe the document, meaning that we use the index term to represent the document. Okay. So which means that whenever we get a document or a set of document, we will look into the content of the document and we search for all these term that has some meaning. Contohnya macam person, things, place, idea, the concept, the item that discussed in the document. So basically, we will ignore all the irrelevant word. Contohnya macam what we call that one, word that do not carry any meaning. Okay, contohnya macam it, is, any. So that is not part of the noun, like in, so all those will be removed. Okay, so the retrieval based on index term can be implemented since we are using specific index term only. So not all index term will be considered. Okay. So what we want to do is we want to select only terms that important or carry meaning so that we can reduce the number of words for describing the document. Okay. So basically, this is the retrieval process in which we have the document here. Let me change. So we have the document here. So each document will be represented by the term or the index term. Okay. So we will not choose all the term. We will only select the one that can be used to define. So when you, as a user, you pass the information, so of course you will key in the query term. Okay. So whatever match here, whatever match index term that we have here, it will be returned to the user. And they have something like a degree of relevancy or ranking. So we use formula to perform the ranking. Okay. In matching this index term and the query term also, between document term and query term, we also have formula in order to match them. Okay. So basically, a ranking is an ordering of the document that reflects their relevance to a user query. Okay, so we will have a number that will be associated with the document here. Each document will have the punya ni lah, scoring. Okay. So the problem to be solved here is how do we predict the relevancy of the document, and based on the index term that we have here, we have the problem what we call the uncertainty or vagueness. Vagueness means we do not have actual matching. We only look into the degree of relevancy. Okay, so if we have a number from 0 to 1, the degree of relevancy, so we could have 0.7 or 0.5. So the degree of relevancy is vague because we do not have exact matching. Okay, so we will look into that one later on. So this is the foundation of information retrieval model. So we can represent them using a quadruple. So the first one is the D, which is a set of logical views for the document in the collection. Okay, so we have the document here, and this is the document. Logical view is referring to the representation of the document in terms of numbers. Okay? So each document will have some sort of term. So let's suppose we have document here. So document 1, document 2. So we have each document. And then we will have on the column is term 1 and then term 2. These are the keywords that we found exist in each of the document here. Okay. So this is the logical view of the document. We will look into this one later on. How do we compute the term document matrix? And we also have the logical view of the query. So similar to that, we also have the logical view of the query here. So we will have same thing also, term 1, term 2, and so on. Okay. And we have F, which is the framework for modeling document and query. So this is the framework that we have. This is the framework. Okay. And we have a ranking function, so in which the function will determine the ranking of the document J with respect to the query that we key in. Okay. So for each document that we have here, okay, we pass to the ranking formula, and then we also get the query, and then based on the formula that we use for ranking, we will compute the similarity between the document and also the query. So this is the basic foundation of IR model. Okay. In a taxonomy of IR model, of course, when we have information, we have text, we have link, we have multimedia. Okay, so when we have text, we look into this Boolean, vector, and probabilistic, and they can be expanded to a more advanced model. Okay, so we will look into this. So once you understand the basic description of Boolean model, vector model, and probabilistic model, then it is easier for you to read other paper related to more advanced model that related to the classic IR model. And of course, we also have the semi-structure in which we have not a fixed structure. So website that use XML is considered as semi-structure. So we can extract the information earlier. Okay. Any question? And for these two, we will not cover in this course. So this is for the link URL. We look into the page rank, and then for the multimedia, we have image retrieval. So this is more into computer vision. We also have audio and music retrieval. How do we match the music and then the video retrieval? Okay, any question?
No, sir.
Yes. Tidak.
Tidak, sir.
Okay. So we will continue. So for the retrieval process, we have two types. The first one is called ad hoc. Ad hoc is spontaneous process in which there is no specific process that we need to go. So for example, like this one for ad hoc, we have a collection of fixed size document, and then query, user one put in the query, and then user two put in query number 2, 3, and so on. Okay, so this is just ad hoc. We also have filtering. So for this one, the document filter for user one based on the profile. Okay, so each one of us will have our unique profile. So the document will be filtered based on user profile. Okay. So just now I mentioned about index term, kan? So index term is actually keyword or relevant keyword that can be used to represent the document. So an index term is a word or group of consecutive words in a document that are chosen to be important term to be used to represent the document. Okay. So this is what we call pre-selected set of index term. Okay. So when we look into the keyword, so we can say that let's suppose we have T be the number of index term in document collection. So that means we have T number of keyword. Okay? T number of keyword. So our keyword will start from 1. Okay, so that means our vocabulary atau dictionary ini starting from keyword 1 until T. Okay. So what we want to have is that we do not want to have a very, very long or a large number of keywords, okay? Because it will take more time to process when you want to compare, okay? To the difference between the document and also the query. So if we assume that our vocabulary is coming from this index term, 1 up to T, so we can get the document and query and then represent them by pattern of term or term co-occurrence. That means whenever that term exists in that query or document, we put number 1. Means on lah. So for this one, for this document contain all the keyword that we have here. Okay. So if we have 3-bit, how many keyword we have here? Anyone? So if we only have 3, how many combination that we could have? It's around 2 to the power of 3. Right? So we could have 0, 0, 0, 0, 0, 1, 0, 1, 0, and so on until 1, 1, 1. So these are the number of document that we could have, different document. Okay. So each of these pattern of term co-occurrence is called term conjunctive component. Okay, term conjunctive component in which each of the term will be combined. So for each document DJ or query queue, we associate a unique term conjunctive component. So we just use this symbol C to say that we have unique term conjunction component. So if I say this is my J, so my conjunctive will be 1, 0, 0, 0. Okay. So each one of these is called term conjunctive component. Okay. So if we want to define the term conjunctive component for the first one, so we use the N because we combine. Yeah? So K1 and then this is not. So not 0 will be 1. So for this one to be true, all of this must be 0 and this is 1. So which is this one. And for the DN, so of course we have 1, 1, all 1. So this one will become true also. Okay. Will you follow? Any question? Can I continue? If you're okay, can you type number 1? Macam 15 orang sejak sewa. Yang lain mana? Baru 20 orang. Okay. So based on this concept, we use that want to define the term document matrix. So the term document matrix, so we have all the keyword here. Okay, this is all your term. And this is all your document here. Sometimes they define this one as your punya document di sini, and you punya keyword di atas sini lah. So sama juga lah. Okay. So this is what we call a term document relation between the keyword KI and also the document J. So this one can be quantified by the frequency of the term in the document. So this is the frequency of keyword 1 in document 1. So this is the frequency of keyword 2 in document 1. Okay. So this is the matrix that they use in to represent the document and also the query lah. So your query could be here. So we have the frequency for keyword 1 in the query. This is the frequency of keyword 2 in the query. Frequency key 3 in the query. Okay. So this is the logical view of how do we process the document. So we have the document here, and then we try to extract the content of the document. So some document may have structure, so easier for us to extract the content. Okay. So once we recognize the structure, then we will look into how do we pass this one, and then we will remove the spacing. We will move the stop word. Okay, the stop word is those words that do not carry any meaning. For example, is the, I, he. So these are sample of stop word that we have. Okay, so we want to remove this. We want to remove all this. Okay. So once we remove them, then we have a small number of words that what we call the noun word. Okay, nouns group. Contohnya macam playing. Or the name of a person. Or maybe we have place. Okay. Or played. Okay, so these are the words that will be kept in this stage. Okay, and the next one will be stemming. So all these three coming from a root word called play. So by looking at this, we are reducing the number of vocabulary from 3 to 1 in this example. So this is what we call stemming, in which we get the root word of the document for all the document that has this one. This is postfix item. Okay. So once we perform the stemming, we get the root word. So we have all the keyword here. Then we have the taxonomic keyword here. So this is the process from full text document to a set of index term. Okay, from here we have here. So these are the process that we have. Okay. So when I go back here, so basically all the index term that we have here are the control vocabulary. Okay, these are already pre-processed. So this is control vocabulary. Okay. Oh, any question?
No, sir.
Boleh follow lah kan?
Boleh, sir.
Tidak juga susah lah kan? Okay. So this is the, let me erase first. So this is the matrix, the term document relation that will be used throughout this courses lah. So each document will be considered as column ataupun row, and then for each document too, we will have a certain keyword that we have, and the number here will quantify the frequency of the term that exists in that document. In your practical later on, we will perform this one using the R software. So it will do it for you, but you have to understand how the process involved behind the building the term document matrix. Okay. So now, if we go back to here, the first one. Okay. So basically, we have look into this, and then we look into the basic concept. How do we represent the document lah? Okay. So this is the most important parts. So now we will look into the Boolean model. The Boolean model, as you know, if you know, this is 0 and 1 only, kan? So Boolean values, we have true, false, and true. So this is false, this is true. So basically, we are dealing with binary number lah. Okay. So if you look at the first model, the Boolean model, this is the most simple model based on set theory and also Boolean algebra. So the Boolean algebra referring to all the operation that we have that include the AND, the OR, and also the NOT. Okay. So in the Boolean model, queries specified as Boolean expression. So this one refers to keyword A, keyword B, and keyword C. So if I read this one, it says this is a query that contains keyword A and keyword B or not keyword C. Okay, so basically we need to perform this one first before we can evaluate this. Okay, and the first thing that we need to evaluate first is this one, number 1, and then this is second, and last one is the drill. Okay? So basically, for us to have this query to be true, 1 and 1. So this is, it could be O and O. I refer to the KC here. So this is the KB. So this is the KA. Okay. So when your KC is 0, but you take the complement, it becomes 1. So 1, if we have O here, so either 1 true, you have true, and then 1 and 1 we have true. Okay. So here we look at the weight as 0 and 1 only. So 0 means does not exist, 1 means exists. Okay, so this is in the document. So this is either a keyword exists in the document. Similar to the query, we look into the keyword that exists in the query. So we just use 0 and 1 only. Okay. Okay, this is the definition of the query conjunctive component and also the disjunct normal form. Okay. A term conjunctive component that satisfy a query is called a query conjunctive component. So when I say this is my query, so the conjunctive component will be one of these. Okay, so this is one of them, the query conjunctive component. But when we have a series of them, a query queue rewritten as disjunction of those components, so we call them as disjunct normal form. So because we have a few more options that can make this query to become true. Okay, so if you evaluate the query based on this number, so if you put 1, 0, 0 here, this one will still give you true. If I put 1, 1, 0, this one will give you 1, similar to this. So either we can use this conjunctive component or this one or this one. Okay, so when we have all of them, we call it disjunct normal form. So disjunct normal form. Okay, so the three conjunctive components for the query will be 1 and 2 and 3. So when we combine them, they become what? They become this, D and F, which is this one. So only the blue area yang what we consider will be written to the no. This is the document that we have. So this is document 1. So this is document 2. So this is document 3. So all this document will be written to the user. Okay. Okay. Let's suppose we expand the vocabulary here. Just now we only have 3, yeah? So let's suppose we have 4 now. So we have keyword A, keyword B, and keyword C, and lastly the keyword D. Okay. Okay, let's suppose we have this one of the conjunctive expression 1, 1, 1, 1, 1, 0. Okay, so 1, 1, 1, 0. So the query that we have is this one. Okay, so if we look back at here, these are all the formula that we have for this query. This query is similar to this. Okay, they are similar, but except in this scenario, we have this extra keyword. Okay. So since we have the disjunct normal form for this query to be only 3, so when we expand this one to 1, 1, 1, 0, 1, 1, 1, 1, it still works because we do not care about the fourth one. We do not care about this. So that's why when we have this query, and given that we have 4 keyword here, then we will have this conjunctive component. So we have this one, and this one means either keyword D exists or not. This is exists, this is not exists. So similar to this, we just expanding them. So now from 3, just now we have, this is 3. We have 3 here. And since one of them, one each, we can expand them to be 2 conjunctive component. So now we have 6 lah, total of 6 conjunctive component. Okay. So now, given that this is how we represent each document, so we can use this function, similarity of document. If if a document and a query to be considered equal, so the value will be 1. Okay, so that means if there exists a conjunctive component of Q such that the conjunctive component for Q is equal to the conjunctive component of document J. So that means all of them match. Okay, all the binary number that we have for the query is similar to what we have in J. Okay, so the Boolean model predicts that each document is either relevant or not relevant. So true or false only. But the drawback for the Boolean model is that we have no option for partial matching. So for that one, due to the fact that we only have true and false. Okay? Yes or no. We do not have maybe. We do not have percentage. Okay? Because the value is 1 or 0 only. So no ranking of document is provided. We do not have the ability to rank the document. Okay? This is because they look for exact matching only. Therefore, that reason they introduced the next one, the next model. They have expanded this one to the term weighting. So the Boolean query formulated by user are most often too simplistic. Simplistic means they only do direct matching. Okay, actual matching. So for that reason, they introduced this, what we call the term weighting. So for the term weighting, they say, okay, why not we quantify the feature based on frequency. So based on frequency, they will look into how do we use that one to weight the term. Okay. You still there? You still okay?
Okay, sir.
Okay, sir.
If okay, you type number 8 lah. Do you need a break? Or do I need a break? We take 5 minutes break lah.